Hello friends, welcome to this course of Moodle in which you will be learning Association Rules a priori algorithm. I am Nandita Singh, one of the tutors of this course. You can find this PPT under the resource folder termed as a priori algorithm.pptx. So let us start with an example of what is association rule mining, right? So here in the screen you can see the computer. Buying a computer tends to buy of antivirus software which is having a support of 1% and a confidence of 50%. So what is meant by this? I hope this support and confidence are the new terms for you. So support of 1% is nothing but 1% of all the transaction analysis shows that computer and antivirus softwares were purchased together. That is, you are having a transactional history. When it was analyzed, you get to know that computer and antivirus softwares were purchased together, and this occurrence has a support of 1%. Whereas a confidence of 50% says if a customer buys a computer, there is a 50% chance that he will buy an antivirus software as well. That is, buying a computer tends to give a 50% probability that an antivirus software will also be purchased along with it, right? So this support and confidence are the measures for this association. And they are defined as support refers to the usefulness, so A tends to B gives the probability of A union B, whereas the confidence refers to the certainty of the discovered rule, right? So confidence of A tends to B, that is confidence of purchase of a computer tends to the purchase of antivirus software, is nothing but support of A union B upon support of A. And a rule is said to be strong and interesting if and only if it satisfies this both thing, that is a minimum support threshold and a minimum confidence threshold, right? So you set a particular threshold, let's say like support should be at least 2%, so this will become your minimum support threshold. And who decides this threshold? This threshold gets decided by either by the domain expert or by the set of users. This is again an important thing. A subset of a frequent item set must also be a frequent item set. What is meant by this? If we say that purchase of computer and an antivirus software together are becoming frequent item set, then both computer as well as the antivirus software should individually be also frequent item set, right? So what a priori algorithm does? A priori algorithm is the basic algorithm to find the frequent item set. It generates the strong association rules. It tries to identify which are the strong association rule, and accordingly you can indicate that these are the frequent item set. Okay, so a priori algorithm uses some prior knowledge of frequent item set, and it has some a priori properties that all non-empty subset of a frequent item set must also be frequent. That likewise we said in the previous slide also. If an item set does not satisfy minimum threshold, then it is not a frequent item set, because we have set a threshold. It has two steps, a join step and a ruin step, right? So here is an example of an a priori algorithm. This example has 9 transactions from transaction ID T100 to T900, and it has respective list of items. For example, under the transaction T100, items of I1, I2 and I5 were purchased. Similarly, under the transaction of T200, items I2 and I4 were purchased. Likewise, each list of items are listed over here in this transactional table. So in a priori algorithm, the first step is you need to find out the frequency or the number of times each item has been occurred. That is nothing but you have to count how many times I1 has occurred throughout this 9 transaction, how many times I2 has occurred throughout this 9 transaction, likewise for I3, for I4 as well as for I5. So let us start calculating. For I1, you can see I1 under transaction T100, under transaction T400, under T500, under T700, under T800 and T900. So you have to list I1 has occurred 6 times out in all the 9 transactions. Likewise, you have to count for I2, I3 and I4 and I5 as well. So their support count is 6, 7, 6, 2, 2. Then you have to make an this is your transaction ID. Now you have to make a 2 item set like I1 along with I2, I1 along with I3, I1 along with I4, I1 along with I5. Likewise, 2 pair item sets are getting, and then you have to count support count for each one of them. For example, I1, I2 together, how many times they have occurred. So let's see I1, I2 together. So yes, they are present in T100, I1, I2 together once. Next time they occur in T400. So now the support count becomes 2. Next time they occur in T800. Now the support count is 3. Lastly, they occur in T900, which makes support count as 4. So you can see in C2 table, I1, I2 has a support count of 4. Likewise, you have to count for each item set. Once C2 is prepared, then you have to compare it with the, in the previous step I forgot to tell that, you have to compare this candidate support count with a minimum support threshold. So here the minimum support threshold is 2. So whatever things which are below 2 will be ignored or will be deleted. So see, I1 and I4 were having a support count of 1. So this has not been reflected in the further table of L2. Now you have to find the support count 3 item sets like I1, I2, I3 and I1, I2, I5. Then you have to count, calculate the support count for it. Then compare it with the minimum support threshold, which is 2. They both satisfies it. So they both are qualifying to go in the next step. Then you have to make a 4 item set I1, I2, I3 and I1, I2, I3 and I5. But it is not possible in this case. Okay, so let's move further. Once the final support table L3 has got, you have to calculate the confidence using the formula support confidence of A tends to B equals to support of A union B upon support of A. So in this case, I2, we are calculating for I1, I2 and I5. So for I1, I2 tends like purchase of I1, I2 giving I5, the support is, so it is nothing but confidence will become calculated as support of I1, I2 union I5, which is 2 upon individually support of I1, I2, which is 4. This data you can get from these tables. So likewise, you will compute the confidence of all possibilities. Now, since our minimum confidence threshold is 70%, so all these association rules which are highlighted are the strong. I hope this concept is clear. This was a very simple example of a priori algorithm. Okay. Hope we'll solve some more example in the next session.